Hello, my dear students. I am Dr. Muneender and I am going to teach you the network theory. Dear students, before we step into the subject, let us look at first of all the complete roadmap of the network theory and what are the textbooks that we need to follow. What is the weightage, of this particular subject in various competitive exams. So after discussing those things, then we will start each and every chapter and the topic and all according to the roadmap given. So let us look at first of all what is actually network theory. The network theory is divided broadly into two categories. One is network analysis. The other is network synthesis. One is network analysis, the other is network synthesis. What do you do generally in network analysis? A network is given, and you are given an input also, and you are expected to find output. A network is given, an input is given, and you are expected to find the output. But what is the output actually here? The output might be a current output or a voltage output. So once you know current or voltage, then obviously you know the power. But whereas in network synthesis, it is quite opposite to the network analysis. You are given output. You are also given an input, but you are expected to realize a physical network using all physical components like RLC elements. So therefore, this is completely opposite. You see now output is supposed to be found when input and network are given. In case of network analysis, here input and output both are given, but you are expected to determine what the network using the physical components. You already know that Laplace transformation of output by Laplace transformation of input with all initial conditions set to 0 is defined as what? A transfer function. A transfer function is defined always with initial condition 0. Of course, without initial condition 0, it is meaningless to define transfer function. I think all of you might be knowing about it. So, if output and input are given means, the ratio of output to input, usually you call it transfer function. That means when the transfer function is given, you are supposed to construct a network using the physical components like RLC elements. Of course, there is no unique network to satisfy a given transfer function. You may have multiple networks. You may construct one network, I may construct one network, and the other gentleman may construct another network. But all of us will get the same transfer function. Or for the same transfer function, we can construct different types of networks. That is why there is no unique network, which can satisfy the given transfer function. That is why there are different people will get different networks. That is why to make it systematic, there are some standard models. You have some Foster form, Coyer form, Foster 1, Foster 1 form, Foster 2 form. Or like similarly, you have Coyer 1 and Coyer 2 form. Like that, you have some different models. You understand? So anyway, we will discuss one after other here. This is very important for. This is very important for GATE, ESC or IES, and any exam that you come across in the competitive exams, PSUs, analysis plays a very important role. But this one, generally the weightage of this synthesis in GATE is almost 0. But in engineering service exams, it is very, very important. And some PSUs are very occasionally asking the synthesis part. That's why we will see one after other. And now first we start with network analysis here. And do not write anything when I'm teaching. I'm going to give you sufficient time to note down the things. So therefore, you look at what I'm explaining here, and later you can note down when I give the sufficient time to you. Okay. So this is what the network analysis and network synthesis here. Now let's look at the roadmap. What are the chapters that we have, and what are we going to discuss? Understand all of you? Okay. We're going to see one after other here. So the first one is the first chapter. The first chapter deals with DC circuits. Okay. In DC circuits, you have fundamentals of DC circuits. You have fundamentals of DC circuits and DC steady state analysis. Understand all of you? Okay. And in DC steady state analysis, you have methods of analysis like node analysis, mesh analysis, and so on and so forth. And of course, you also have DC theorems in this. So therefore, I just divide this into, you have methods of analysis like node and mesh analysis and DC theorems. Understand all of you? Then second part, the second chapter deals with AC circuits. Okay. And again you have fundamentals of AC circuits and AC steady state analysis. Okay. AC steady state analysis. Do not write anything, I will give you sufficient time. Again you have node and mesh analysis, how to solve the networks. There is no much difference between DC steady state and AC steady state analysis. Here you deal with all real numbers, whereas here you deal with complex numbers. Yes or no? Then here, AC steady state analysis in this, AC theorems. You're dealing with what? AC theorems. What is the difference between DC theorems and AC theorems? The statements are same, except maximum power transfer. All statements are same for the Norton's theorem, Thevenin's theorem, superposition, intelligence. Okay, every theorem is same, Millman's and everything, except what maximum power, that we will see. Okay. Now other topics like in this, you have resonance, you have locus diagrams, and you have three-phase circuits, which is very, very important for electrical students. Okay, as far as GATE is concerned, but in IES or engineering service exam, for EC and EEE, both the students, this particular topic is also very, very important. This is the second chapter it deals with. And now the third chapter, which is more interesting and challenging. The third chapter here, okay, transient analysis. Transient analysis. In this you have basically three important modules. One is the initial conditions. Second one is the application of differential equations. And third one is application of Laplace transformations. Okay, but according to me, if you really want to become master in all these topics like initial conditions, application of differential equations, Laplace transformation, or else as a matter of fact in the entire transient analysis, let us say, one should be expertise in understanding the characteristics of inductors and capacitors. So if you really understand the characteristics of the inductors and capacitors, you can easily deal with the transient analysis. You never face any problem. Understand all of you? So that is why before I start transient analysis, I start with the inductors and capacitors, having certain problems, concepts and everything. Even exam point of view, there are specifically people are asking the questions in this particular topic as well. Okay, therefore, that is one reason I'm including here, that is characteristics of what? Inductors and capacitors. We're going to study inductors and capacitors. And you have initial conditions, application of differential equations, and application of Laplace transformation. That means how we are going to apply the differential equations and Laplace transforms in the case of transient analysis. We are not going to discuss how to solve the differential equation, how the transformations are derived. I'm not going to really explain you, but I'm going to explain you how we apply these things, differential equations and Laplace transformations, to determine the transient response or the time response of any given circuit. Understand all of you, okay? Well, so this is what the major topic actually. You can expect at least one question or two questions. Usually you're getting frequently, the questions from the transient analysis, including inductors and capacitors. Directly you're getting some questions in the inductors and capacitors in the competitive exams. And as I told you, if you understand this particular topic, you can enjoy the remaining three topics. Okay? Well, the fourth topic is magnetic coupled circuits. Magnetic coupled circuits. And the fifth one is two-port networks. And the sixth one is network topology, duality, passive filters, all these three topics we will see in this particular chapter. And the seventh chapter is network synthesis. This is useful only for engineering service exam, as I told you. For GATE aspirants, this topic is not that important. So far, I think almost no question has come in the GATE. Okay? Network synthesis. So this is a complete roadmap of our network theory. Network theory is divided into two parts: network analysis and network synthesis. Now all this, first, second, third, fourth, fifth to sixth, up to this particular part, it comes on network analysis only. And the seventh chapter we are discussing what? Network synthesis. Understand all of you, okay? Now you need to understand the textbooks, what kind of textbook that you need to follow, and what is the weightage, how many marks are you getting really. Okay, the marks in GATE examination, it is a minimum 7 marks to 14 marks. And in IES, you can find numerous number of questions. I'm telling at least 20 to 25 marks you are going to get in the engineering service exam. In every PSU exam, state government PSU or central government PSU or any other department, government job, you will definitely get a minimum to minimum 7 marks, I'm telling you. So it's not only important directly to score the marks, but also indirectly, even to analyze. Tomorrow you're dealing with control systems and analog circuits, signals and systems, let us say. Even the electrical students, I think you're going to deal with power systems, power electronics, measurements and machines. If you're really having command over the networks, I'm sure that you are going to enjoy all those topics and you can indirectly score a lot in any competitive exam. Understand all of you, okay? So this is the weightage of the particular subject. And what are the standard textbooks? Textbooks nowadays, I think most of the students are not reading properly. In our generation, we used to follow the standard textbooks. And you see, most of the questions are taken by these IIT professors when they design the paper. Okay? They're directly picking up the questions and from the standard textbooks and slightly modifying that and giving in the actual any gate examination or engineering service exam. So do not neglect them. At the end of each chapter there are certain questions, and of course our material is also going to cover several questions over there, but you also need to follow the standard textbook. Understand all of you? Okay, there are two reasons why we are suggesting the standard textbooks along with any material suggested by whether it is Vishwa or anybody or whoever it is. Why we suggest here standard textbook here is, it's all because tomorrow you are going to attend for any interview. The interviewer may go out of box. Okay, don't think that they're going according to the syllabus. So when you do not follow the standard textbook, the interviewer will focus on the concepts from the standard textbook, and he will also expect all those things from you in the interview. So if you do not really answer the questions to their level, then obviously you may not succeed in any particular interview. That is why students, you must be a little careful, and this is the most important point to be observed. Most of the students are neglecting nowadays, but you don't neglect. Okay, textbooks, let us take for the networks. The first one is, I would suggest, okay, engineering circuit analysis by William Hayth and Jack Kemmerly. And the second book is Fundamentals of Electric Circuits by Alexander and Sadiku. The third textbook is a fantastic one, Network Analysis by Van Valkenburg. The fourth one is very good for problems oriented. Of course, you find a number of problems in these textbooks, but you have a textbook which is completely dealing with the problems and variety of problems, that is Electric Circuits by, okay, Joseph Administer. Joseph Administer. These are the standard textbooks one should really follow. This is the weightage, and this is the complete roadmap. Okay, and you please first note down all these things carefully and document it properly. Everything that I explain here, you are going to document, because tomorrow it is going to be useful to you. And I repeat once again, do not write anything until I give an instruction. Your focus must be on my lecture first. And once you really, understand the concepts and I give a sufficient time here, don't worry, you can document it. And tomorrow, whenever you have a doubt, you can easily refer the notes. That will help you a lot. Understand all of you? Okay. Now I am giving you a 3 minutes time to note down all these things. It will be sufficient. Please carry on with this. Number and email ID. Clearly, I am writing here. And my mobile number. Okay, now let us look at certain important definitions. Now we are starting with DC circuits and fundamentals of DC circuits. Okay, and let's start with certain important definitions which you already know very well, but still we'll try to close it. Okay, so what is actually a network, and what is a circuit, and what is the basic difference between a network and circuit? How do you define a network basically? What is a network? A network is nothing but what? A combination of various electrical elements. Yes or no, all of you? Okay. Combination of various electrical elements. But what about the circuit? It is also a combination of various electrical elements, but with at least one closed path. Yes or no, all of you? You just take the elements and connect them, it forms a network. And now you observe, if that combination is consisting of at least one closed path, then we can say that it is a circuit. Yes or no? Okay. That's why you can say every circuit is a network, but every network may not be a circuit. You understand, all of you? Every circuit is a network, but every network may not be a circuit. I hope you understand the point. So write down the points here. When I'm going to dictate certain notes, my dear students. I give the notes, I'll give you sufficient time to note down the things, okay? So you just feel like it's a classroom. A classroom is in front of you on your computer. I'm going to explain and I'll give you sufficient time to note down the things. I'm going to dictate the points, everything you must maintain, just like in the classroom. Only difference is that I'm not there in front of you. Instead, I'm there on your computer screen, okay? So take down, what is the network? A network is, write down, a combination of, or else you can write down like this. It is a combination of various electrical elements. It is a combination of various electrical elements. Circuit. It is a combination of various electrical elements. It is a combination of various electrical elements with at least one closed path. It is a combination of various electrical elements with at least one closed path. Some examples, let us see now. You call it a network or a circuit? Yes. You can call it what? First, it is a network, yes or no? Since it is having closed paths, it is also called as what? Circuit. It is both network as well as circuit. Second one is, let us see. So what is the circuit that you define? A combination of various electrical elements with at least one closed path. Actually, why you want a closed path? For the sake of certain amount of current to flow in that closed path. Yes or no? Look at this. It is a combination of various electrical elements, therefore it is called network. Is it having any closed path? Yes, there is a closed path, it looks like. But do you expect any current in this particular closed path? Because it is open circuit, can you expect any current in this particular closed path? You cannot. Therefore, it looks like a closed path, but the current flowing in this particular closed path is how much? 0 ampere. So I don't have a purpose of having the closed path here. It's not meeting my purpose here. I expect that closed path, okay, and in which there is always certain amount of current flowing. Yes or no, all of you? That is why I call it only network, but I cannot call it a circuit, because it looks like a closed path, but there is no current. But I want a closed path only for the sake of current. Yes or no? Okay. Well, now here, third example. Look at this. What about this? Absolutely network, but it's not a circuit. Yes or no, all of you? So look at this. Every circuit is a network, but every network may not be a circuit. That point is very important. All of you, please note down these three examples. Then we write a point. Put a note and write down. Put a note and write down. First, you note down these three. I think all of you written that. What is the network? Combination of various electrical elements. What is the circuit? Combination of various electrical elements with at least one closed path. Now note down these three examples here quickly. Write down here, note, every circuit is a network. Every circuit is a network. but every network may not be a circuit. Every circuit is a network, but every network may not be a circuit. Because circuit should definitely have at least one closed path. But the network is simply a combination of various electrical elements. It may or may not have a closed path. Understand all of you? Okay. So this is how you define network and circuit. So now another important definition. What is a node? Node is nothing but what? It is a point or connection. Or it is a point on the network where at least two elements are connected. Two or more elements are connected, or at least two elements are connected. Look at this. Can I call it a node because how many elements are connected? There are three elements are connected, or three branches are connected here. Yes or no, all of you? Okay. Three elements are connected. Therefore, I can say the degree of this particular point is the degree of this particular point, connecting point, is 3. Now you tell me, how do you define node? Any connecting point on the network with a minimum degree 2. Because what is the degree? Degree is nothing but number of elements connected at that particular point. Now that point, if it is having the degree minimum 2, then we can call that particular point as what? Node. So what is a node? Any connecting point. Any connecting point on the network with minimum degree 2. Please write down. Any connecting point on the network with minimum degree 2. You understand all of you? Any connecting point on the network with minimum degree 2 is called a node. I can call it node. Why? Because what is the degree? 1, 2. I can call it a node because the degree is 1, 2. I can call it a node because the degree is 1, 2, 3. Can I call this as a node? Yes, we do. Because what is the degree? There are two elements connected at this particular point. Therefore, I can call this particular point as node. Node. But it is not a node. What is the reason? Because there is only one element connected at this particular point. Therefore, I cannot call it as a node. The degree is only 1 here. The element is just floating in air. And there is no other element connected at that particular point. The degree is 1. But the degree must be 2 to call any connecting point as a node. Okay? So this is how you define a node. And very simple that the degree should be minimum of any connecting point. Then we can call that connecting point as a node. What is a branch? What is a branch? What is a branch? It's nothing but a path. It's a path between two nodes. Okay, it's a path between two nodes. Path between two nodes is said to be path between two nodes. Is nothing but a branch. Okay, but the path may have one element or two elements or n number of elements. Doesn't matter. All elements might be connected in series. One element or two element or three element. All elements are connected in series. Then that can be treated as a path. At any path that is connected between two nodes, okay, you can treat that particular path as what? A branch. Yes or no? Okay, so I think you have written this. Branch is nothing but what? A path between two nodes. Please note down. Now let us see one example which was asked in one of the competitive exams. Sometimes he may ask you, by giving a network, how many number of nodes and how many number of branches are there. Number of nodes and number of branches. Note in the question, the first question, example, on this particular branch nodes, okay. Let's see some examples here. Number of nodes and number of branches. in the following figures or figure. A, n is equal to 4, B is equal to 5, B, n is equal to 3, B is equal to 4, C, n is equal to 2, B is equal to 3, D, all the above. Okay, look at this. Okay, it's a very simple question. Look at this. Number of nodes and number of branches. Okay, all of you, I think you might have noted down, or else please note down first. Number of nodes, number of branches. Okay, note down first. N is equal to 4, B is equal to 5, N is equal to 3, B is equal to 4, N is equal to 2, B is equal to 3, all the above. Okay, how do you generally count the number of nodes and number of branches? How do you count? What is the procedure to count? What is actually a node? As per the definition of a node, any connecting point on the network with minimum degree 2. What is the degree of this particular connecting point? 2. I can call it a node. What is the degree here? 2. Node. Sorry, 3. Okay. The degree is 3, therefore node. The degree is what? 2. The degree is what? 1, 2, 3. Therefore, there are 4 nodes. And now, any path between 2 nodes is called a branch. So if you count the number of nodes and number of branches, it looks like this. 1, 2, 3, 4, 5. Yes or no? Number of nodes and number of branches. So it looks like the first option is readily available. Definitely this is the correct option according to this count. Yes or no? But look at this, all of you, there is an answer called all the above. Sometimes the given question may have more than one answer. Yes, it is possible sometimes. So let us be very clear with the concept first. Based on that, we can try to answer it easily. Yes, the first option is correct, no doubt. But look at this. Node A, when it is taken here, what is the degree of this particular point 2? Yes or no? But how these two elements are connected here? They are in series. Yes or no? Now, if I treat this 1 and 2 as a single path, okay, if I treat this branch 1 and branch 2, if I treat this 1 and 2 branches, okay, as a single path, first element and second element both are treated as a single path, then node A, does it come into picture? It does not. Yes or no? Okay. Therefore, in this case, if I treat, because what is the branch actually here is the path between 2 nodes. That path may have 1 element or 2 elements or a number of elements in series. Now, if I take this 1 and 2 as individual branches, then definitely node A is coming to picture. Because 1 is between AD, 2 is between AB. I can read like this. I can read like this. All of you can easily understand with this particular interpretation. 1 is between AD, 2 is between AB, but 1, 2 together between BD you can say. In such cases, node A does not come into picture. Then what happens here? Branch 1 and 2 together can be treated as one single branch. Then obviously, number of nodes B, C, D, number of branches 1, 2 together 1 and 3, 4, 5. This is also correct option. You understand? Can I give the same explanation even for 4 and 5 because they are also in series? Then this is also correct. Because 1 branch, 2 branch, 3 branch. Now only B and D are coming to force or coming to picture. That's it. So what is the option here? All the above. I think all of you understand the concept here very simple. The number of nodes and number of branches, the count may not be unique. You may get one answer, I may get another answer, and somebody may get some other answer. It all depends on how you are counting. Especially this difference comes among all the people who are counting the number of nodes and branches, especially when there are series connected elements. In case of series connected elements, if you treat this each and every element as a branch, then you get one count. Then if you treat that the two elements which are connected in series as together treated as one branch, then you get another count. Do you understand, all of you? Okay. So this is how you need to count the number of nodes and number of branches. So therefore we can say the count of number of nodes and number of branches may not be unique, especially when there are series connected elements. But the number of loops, L is equal to what? B minus N plus 1. What is B stands for here? Number of branches. Number of branches and number of nodes. Number of nodes. Yes or no? But what L stands for here? L stands for what? Loops? No. Not simply loops, it is number of fundamental loops. Fundamental loops. How many loops are there? 1, 2, 3. But how many fundamental loops are there? 1, 2. That's it. There are only 2 fundamental loops. But number of loops you can count. Any closed path can be taken as a loop. But the fundamental loops are how many here? Only 2. You understand, all of you? Now you see 5 minus 4 plus 1, 2. 4 minus 3 plus 1, 2. Now 3 minus 2 plus 1, 2. You are getting the same answer for what? Number of fundamental loops. No doubt. But the count of number of nodes, number of branches may not be unique. So therefore, please note down here the point. Note. 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 All of you write this point. Note. The count of number of nodes. The count of number of nodes and number of branches. All of you note down? The count of number of nodes and number of branches may not be unique, especially when there are series connected elements. Especially when there are series connected elements. So please note down this quickly, all of you. I give you a minute. Now let us look at another example, second example. Now you can easily answer it. Now you can easily answer it. How many nodes and how many branches are there? N is equal to 1, 2, 3, 4. Yes or no? N is equal to 4. B is equal to 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, you are getting 6. 6 minus 4 plus 1, according to that L, 3 fundamental loops are there. There are many loops actually, but how many fundamental loops are there? Only 3. Okay, this is one answer. But before you conclude this answer, check whether there are any series connected elements. In the first count, we did not consider these two as individual branches. We had taken these two as a single branch. Therefore, that is why you got this answer. But if you treat there is another point, because this is also counted as a node, because the degree is 2. If I count it as a node, then the 2 branches will come into picture. That's why you get N is equal to 5 and B is equal to what? 7. Okay. You have another answer because there is one more series combination. What is this series combination you see here? Yes, there is one more. Yes or no? So N is equal to 6 and B is equal to 8. That's it. L is always 3. Irrespective of the count that you take, L is always 3 here. Understand all of you? Okay. So this is how you are supposed to, in fact, you're supposed to take or count the number of nodes and number of branches. Simple when the network is given. The first, observation is that whether there are any series connected elements or not. If there are series connected elements, the count may not be unique. Okay? The count may not be unique and you may have multiple answers. There is no single answer. You may have multiple answers. So please note on that. Okay, I think you have done with that. Next one is classification of elements. How many types you classify? You can classify, linear element, non-linear element, active element, passive element, unilateral element, bilateral element. Like that you can classify. So the first classification, let us look at. What is that? First classification is active element, passive element. Okay. So I discuss by these points after a little break. Okay. A 10 minutes break I'm going to give you active element and passive element. Okay. I just stop the session here and in the next session I will discuss the classification. What are the classification? Tell me. The first classification is active passive. What is the second classification? Linear, non-linear. What is the third classification? Tell me. Unilateral, and bilateral. Unilateral element and bilateral. This is the three classification you have, three types of classification we can see, and we can see all these things in the next session. Okay. So I stop here and we'll come back in the next session.